Hello everyone and welcome to today's lesson, which is on, I'm about to tell you after this slide. Okay, let's take a gander at these two equations. These are two forms that we've seen. One we learned the name of, the other one we just kind of learned how to graph. So the first one you should recognize as slope-intercept form. Slope-intercept form. It's called slope-intercept form because when it's written as y equals, when we see this, it's very easy in the equation to see the slope and to see the intercept. Okay, the y-intercept. And this is really convenient for graphing because we can start here and then use the slope as a pattern to find a bunch of other points on our line. Down here is standard form. Doesn't get much more exciting than standard form. It's my old fallback. You learned two methods for graphing standard form. The first method was to turn it into slope-intercept form. So you turn it into slope-intercept form, you solve for y, and then you go ahead and graph. The other way was to pick points. You pick points and solve for the other coordinate and plot those points. And the points that I recommended starting with were x equals 0 and y equals 0. Okay, you can do that with slope-intercept form too. You can do it with any form, but those are the great techniques for graphing in standard form. X equals 0, by the way, is the y-intercept. And you can see that here if you plug in 0, and y equals 0 is the x-intercept. Cool, but you can pick any other point you want, like y equals -3 or x equals 800. You can pick any point you want, except 800 would be tough to graph. Today we're going to learn about a third form called PointSlope Form. It is called PointSlope Form because when it's written in this form, you can see the slope and you can see a point, one point that line travels through. Kind of exciting. I think it's kind of exciting. So where does this come from? Whew, okay. Where does this equation come from? Sure. The equation comes from the slope equation that we learned before, right? We learned this slope equation a while ago that said y2 minus y1 equals x2 minus x1. Now, every single linear equation is going to have a y to the first power and an x to the first power. Standard has an x to the first power, y to the first power. PointSlope has a y to the first power and x to the first power. Okay, good to know. So let's see here. I'm going to move this down a bit. How do we get, from here up to here? Well, it's as simple as cross multiplying. If you can imagine this over 1, we cross multiply, it'll be m times x minus, or x2 minus x1, and that will be equal to y2 minus y1, which is close. We've just substituted out for x and y, a general y and a general x. That's all it is, and that's where our equation comes from. It's kind of exciting. Okay, great. So y minus y1 equals m times x minus x1. So what's the big advantage of point-slope form? The big advantage is that it can be very, very fast to write an equation in point-slope form if you have a point and a slope. Let me show you. Let's do it the old way first. Here was how we wrote an equation in slope-intercept form if the equation passed through -5, 10 with a slope of 2. Okay, for us to do that, we wrote y equals mx plus b, just like this, and then we plug in our slope with step 1, y equals 2x plus b, and then we plug in a point. That would be 10 equals 2 times -5 plus b. We're going to simplify and solve for b, which was step 3 that I gave you. Okay, now to solve for b, we're going to add 10 to both sides. Great. So that ends up being 20 equals b, so our last step is to write our final equation, which is y equals 2x plus b. Fantastico. We got plus b. Golly gee, it's late. let's forget that happened. Plus 20, thank you. We'll take that out in post. Right, Steve? We're taking that out in post. Okay, now let's do the same problem with point slope. How fast is this? Well, point slope, let's write our equation. Y equals, and I'm actually let me change the color really fast. Y equals, again, it's late. Y minus y1 equals m times x minus x1. You gotta get in the habit. We're not writing slope intercept anymore. Okay, now we plug in the coordinates of the point and the slope at the same time. So we're gonna do y minus whatever our y coordinate is. Our y coordinate is 10, so it's y minus 10 equals m, which we know is 2, times x minus x1, which is our x coordinate. But here our x coordinate is minus 5, so we have to include both subtractions there. So it's y minus 10 equals distributing, or rather not distributing, simplifying, 2 times x minus negative 5 is x plus 5. So there we have point slope form. It is completely simplified. It's really fast to write the equation of the line very quickly. And it turns out that you can also go very quickly from point slope form into slope intercept form. So really quickly now I can distribute if I want. So it could be like y minus 10 equals 2x plus 10. Add 10 to both sides, and you'll get y equals 2x plus 20. Same equation, the same equation we got over there. So if this is also a technique for using point slope form is also a technique for getting equations into slope intercept form. I'm sure that was super clear. Okay, I gotta start recording these videos a little earlier. For each equation below, find the slope and a point that it passes through. So for these ones, we are going to just look at the equation and we're going to pull out the slope and a point. And some of them are a little clearer than others. Let's take a look-see here. Okay, so the equation, remember, was y minus y1, y coordinate of our point, equals m times x minus x1, which is the x coordinate of our point. And we need to keep a regular x and a regular y in our equation, right? So we don't plug in for this when we're plugging in our point. All right, so let's go ahead and do this. So what's our slope? The slope is whatever we're multiplying this group of parentheses with the x by. In this case, it is negative 3. And remember, this says our x and y coordinates, right? This is for x1 comma y1. Our xy coordinates, it's what we're subtracting. So here, it's y minus 6. We are subtracting 6, so a 6 goes in here. And then here it's x minus 1, we're subtracting 1. Now notice that it's negative in the equation here, positive in the point. Negative in the equation, positive in the point, okay? So it kind of is the opposite of what is written in the equation. That has to do with the fact that it's what we are writing in what we're subtracting, not what we're adding. Okay, let's look at this next one. Okay, this one doesn't really look like it's in point slope form, and that is because something's missing. If you're looking, it's whatever we're being subtracting from y. So what are we subtracting from y if nothing is written? We can rewrite this as y minus 0. That is the same, equals 1/2 x plus 2. That is the exact same equation as the one that is written next to it, sorry. They are equivalent equations. And now it's very apparent, or it's more apparent, what the point is. The slope was pretty apparent before, but our slope is 1/2, and the point that it travels through is always what we're subtracting. Y minus 0, which means it travels through 0, and then here, well, that's not super clear because we're not subtracting, we're adding. So what you have to do is get creative. You have to rewrite it as x minus negative 2, because I know that x minus negative 2 is the same as x plus 2. So what are we subtracting? We're subtracting negative 2. If you look at the original equation, you're basically taking the opposite of what's present in the equation and putting it in there. That has to do with that minus sign. Okay, how about this one? Nothing is written for the slope. This one's a little funky. Absolutely nothing is written for the slope, and that goes back to this. What is the coefficient of just the variable x? What number is written out in front of it? That, of course, is 1, right? If you see negative x, the coefficient is negative 1. If there's nothing written out in front of the parentheses, the number you're multiplying those parentheses by is 1. So let's go ahead and we could rewrite this with a 1. It's not going to make a huge difference, but we do have this plus sign here, so we can think about that as y minus negative 3. We want to write it as a subtraction, equals 1 times x minus 1. Okay, now it looks like this form, so we can say our slope is 1, and the point that it passes through is x, we're subtracting 1, y, we're subtracting negative 3. Beautiful, 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 beautiful. Okay, if you want to try one on your own, I'm just going to make one up real fast. You guys try x plus 4 equals minus, or sorry, y plus 4 equals minus x plus 9. You guys go ahead and write that in use PointSlope Form to write the slope and the point that it passes through. The slope it has and the point it passes through. And you can go ahead and pause the video if you want to try it on your own. Okay, if we're rewriting this, it would be y minus negative 4 equals negative 1 times x minus negative 9. Okay, and the reason I'm writing it this way is not because this is a more correct version. This is the most correct version to read. It's because this allows us to see the point and the slope a little clearer. All right, and as negative 1, our x coordinate is going to be negative 9. That's what we're subtracting, opposite of what's here. And our y coordinate is going to be negative 4, opposite of what is there. Fantastic. Let's graph. Taking a look. How does graphing in PointSlope form any different than y-intercept form? It's really not. The only thing that's different is instead of starting at the y-intercept, you start at the point that you're given. That's your starting point, and then you use the slope from there. So let's go ahead and identify. We got a slope of minus 1, and the point that it passes through is opposite. It's plus here, so it's going to be minus minus 2, which is negative 2 for that, and a positive 5. So I'm going to go to negative 2 and up to 5. Oh, so pretty. It's got a slope of minus 1. To write that as a fraction, it'll be minus 1 over 1, or minus 3 over 3, or whatever. There's an infinite number of those that you could write. So if I go down 3 to keep my slope negative, I'm going to go over 3, and I can repeat that pattern across my graph. Or I could do up 1 over 1 or up 2 over 2. It doesn't matter. All of them are going to be the same as long as the rise is equal to the run headed downhill. It's all downhill from here. You know, I feel like some people use that slogan to mean something positive, like riding downhill is easy. But then some people are like, things are going downhill, like that means bad. But I feel like, I don't know, I feel like, yeah, riding down a hill is the way to go. Good old kinetic energy. Write in PointSlope form. Let's write this in PointSlope form. Okay, to write it in PointSlope form, we need a point and a slope. So first thing I'm going to do is run through here and grab the points that I'm pretty sure it passes through. It looks like we have a fairly clear pattern here across our graph. And so you can come through here and you can figure out the rise of the run. My slope is positive. I'm going uphill. I'm going up 1 and then over 4. So it's m equals 1 over 4. And now I get to pick a point. And ladies and gentlemen, it does not matter which point you pick. But we need to pick a point so we can write it in PointSlope form. This one, let's do this one here. We'll pick this one and maybe this one and see what happens. This is the point 2 comma minus 1. And if we plug that in for PointSlope form, that's going to be y minus negative 1 equals, our slope is 1/4 times x minus 2. Okay, y minus -1 is really a y plus 1. I'm going to go ahead and distribute my 1/4, so you're going to end up with, oh dearie me, you're going to end up with, we distributed, 1/4 times x is 1/4 x, 1/4 times a -2 is going to be -2/1 times 1/4 is 2/4, or 1/2. Now to solve this equation, I take away 1 from both sides, and you'll get y equals 1/4 x minus 1.5, or minus 1.5, however you want to write it. So here it is in point slope form, done. I got a little ahead of myself. This is it in point slope form. This is it in slope intercept form. The reason I'm writing it in slope intercept form is because I want to show you that, so I went above and beyond there. I want to show you that these two are the same thing. I can choose either point and it represents the same line. So if you choose this one, you get -10, -4. So if we're plugging that in, that's going to be y minus 4, y plus 4 equals 1/4 times x plus 10. So here's the thing. This is also a correct answer in point slope form. So when I say write an equation in point slope form, if you wrote this, that would be correct. If you wrote this, that would also be correct. So the downside of point slope form and writing something in point slope form is that if you get an answer and your friend gets an answer, you could get two different correct answers. And that's kind of frustrating. So to verify that your answer is correct, which is what I got ahead of myself doing earlier, you can write it into slope-intercept form, because there's only one version of slope-intercept form, but there are multiple versions of point-slope form. Okay, so let's do that. I'm going to distribute, so you get y plus 4 is equal to 1/4 x, 1/4 of 10. 10/1 times 1/4 is 10/4. All right, so that I'm going to subtract 4 from each side. Ooh, this looks like fun. Fractions. Y equals 1/4x, and then 10/4 minus 4/1. Well, I'm going to go ahead and simplify 10/4 real fast. 10/4 is equal to 5/2. Yeah, let's make those numbers smaller. And if we're subtracting 4/1, let's actually subtract the halves. So it will be plus 5/2 minus 8/2. Because 8/2 is equal to 4. So when we're adding 5 minus, so that'll be y equals 1/4x minus 5 minus 8 is 3/2. Hey, 3/2, that's equal to 1/2. So it doesn't matter which point you pick, you're going to get the same line in slope-intercept form if you were to convert. These are both correct based on the directions that you were given. Both of them are in simplified slope form, point slope form. If you'd left it as y minus -4, that's not simplified point slope form. So make sure you simplify that. Okay, the last one is write an equation in point slope form given 2 points. So if you're given 2 points, remember you need a point and a slope. Well, we got the point. What we don't have is the slope. So that's step 1. Step 1 is to find our slope. If you want to pause the video and do a refresher on this, see if you can get it. Give it a shot. Okay, so we're going to do y2 is -2 minus y1, which is 1, if we're calling this point 2 and this point 1. And then x2 is -7 minus x1, which is, oh man, I'm all over the place. This is supposed to be a 9, sorry, caught my mistake. So that is y2, which is -2, minus 9, and then -7 minus 1. Perfect. So you end up with -11 over -8, which is 11/8. A negative divided by a negative gives us our positive. That's a nasty slope, but we got the slope. Okay, our slope is 11/8. Now to write this in point slope form, all that we have to do is plug into our equation. So we're going to write this as y, and let's pick point 1. It doesn't matter which point we pick. To write it in point-slope form, you can be done just by doing y minus point slope. Let's do point 1 here. Y minus 9 equals 11 over 8 times x minus 1. Done. Cha-ching! Game over. Okay, if you chose point 2, your answer would be y minus negative 2, which is y plus 2, equals 11 over 8. Changing the sign, x plus 7. Pretty exciting. Okay, now, so this is with point 2. Now, let's make sure that they are the same in point-slope form. Good way to check. Just torturing you guys with fractions. Distributing here, 11 over 8x minus 11 over 8. 11 over 8 times negative 1. We're going to add 9 to both sides. Add 9. So you end up with y equals 11 over 8x. And then right here, that's going to be 9. I'm going to do an aside. Okay, just to show my work. 9 minus 11 over 8 is really the same as 9 minus 8 over 8 minus 3 over 8, because 8 over 8 is 1, 8 plus 3 is 11. We're still subtracting 11 eighths. I've just rewritten it, and 8 over 8 is 1. So it's really 8 minus 3 over 8, which is really 7 and 5 eighths plus 7 and 5 eighths. Great. Fantastic. Oh, that's not in point slope form, so I'm not going to write it that way. Okay, and then right here, we're going to write this to check to see if it's the same. Let's do that. I'm going to distribute 11 over 8, so you get y plus 2 is equal to 11 eighths x. Let's fit this to screen, shall we? Boy, that's a lot larger than I thought. Distributing 11 over 8 times 7 is plus 77 over 8. So we have here now, we need to subtract 2 from both sides. So this is going to be y equals 11 over 8x plus 77 over 8 minus 2 in terms of eighths would be minus 16 over 8. 16 over 8 is 2, so we're subtracting. 77 minus 16 is going to be 11 over 8x plus 61 over 8. Okay, so this one's 61 over 8. This is 7 and 5 eighths. Let's double check. 7 and 5 eighths. Why am I writing my fractions like that? I always tell my students not to do it. Got to be a good role model here. You can multiply the bottom and add the top. So 56 plus 5 is 61. So these two equations are the same. Fun, fun, fun. All right, guys. Thanks for watching. The 2-5 worksheet is on there. Have a lot of fun with those problems, and come to office hours if you need help. Thanks for watching.